Hello my dear friends, welcome to our YouTube channel ADC Maths. See the title, identify the following functions. It is even function or odd function or neither even nor odd. So but when we are going to discuss whether the function is even or odd or neither even nor odd, only in the interval either minus pi comma pi or in the interval minus L comma L in general, right? So what is mean by the function is even? When we call it as the function is even, the function is even only when f of minus x is f of x. That means when we change its axis x by minus x, we get the same answer. So there is no change. It's called even. If there are some changes are there by replacing x by minus x and f of minus x, we get minus f of x called odd function, right? And what about the product of two function? Even into even is even into odd is odd. I think already I given a separate video for this even and odd functions. Please kindly just go and check. Once again, watch those videos. Plus into plus is plus. The same concept. Plus indicates the even function. Because after replacing x by minus x, we get this plus 1. After replacing minus x, we get minus. So minus indicates the odd function. So once if you are familiar, this basic product of two signs, plus into minus minus, minus into plus minus, minus into minus is plus. So here minus indicates the odd function, plus indicates the even function. Okay. Now my question is whether the given following functions are even or odd. There are many varieties are there. The polynomial functions, exponential functions, trigonometric functions, hyperbolic functions, modulus function, constant functions. There are many kinds. Let us see one by one. So the first one, actually this can be divided into two parts. Here these functions are defined in only single interval. Suppose it can be defined into two subintervals, then the approach is different. If it is once it is split into more than one subinterval, then the approach is different one. Let us see the another video. See that in this problem we are going to check whether the function is even or odd. So the one by one. The first one. What's first one? The first one, f of x is equal to x in the interval minus pi comma pi. Is it open interval or closed interval? We don't bother about it. Minus L comma L or minus pi comma pi. Now replace x by minus x. I am getting minus x. Is right, sir? This is equal to minus of f of x. Why? Because x. What's the x? X is equal to f of x. So this is looks like f of minus x equal to minus f of x. So that this is an odd function. By the definition. That's it. Clear? This is the way to get the whether it is even or odd. What about the second question now? The second question is f of x is equal to x square in the interval minus 4 comma 4. We don't bother about the numbers, but it is the closed interval. This looks like the L comma L model. So let us check whether it is even or odd. Now replace x by minus x. I am getting minus x to the whole square. What is the minus x to the whole square? Plus x square. What is plus x square? Is nothing but the given function. So even though when we replace x by minus x, I am getting the same function f of x. So that's why this is an even function. From this what we conclude that polynomial functions with the odd degree is odd function, with the even degree it is even function. When you go for power 4, 4 means always positive only. Power 3 means it becomes minus, so it is odd function. What about f of x is equal to k, some constant k in the interval minus L comma L. Can you replace x by minus x? There is no x at all. So again this k. This is constant function. This is equal to f of x. So f of minus x is equal to f of x. So this is always even. So constant functions are even only when if they are defined in a single interval. Suppose it can be defined in two subinterval. The answer may not be. Let us check it out, right? In this next video. Now, what's the third one? The third question is, the third problem is pi squared minus x squared. So let us replace x by minus x. So pi squared minus of minus x whole squared is equal to pi squared minus x squared. once again this is equal to f of x. So what do you say? It says that it's an even function. Where is it? Is it right? Third one. Clear? Now the fourth one. What's the fourth one? Fourth one somewhat interesting one. Fourth one, let us see that. Fourth one, f of x is equal to x plus x square. X plus x square. Now can you replace x by minus x? I am getting that minus x plus minus x to the fourth square is equal to minus x plus x square. Isn't it? This is equal to f of x? No, sorry. So this is not equal to f of x. So this is not an even function. Sorry, this is not an even function. So it may be an odd function. So it's an odd function means what I mean that can we take the minus sign outside? This gives x minus x square. I think so. My given f of x is x plus x square. So sorry, once again this is not equal to minus f of x even. So this is not equal to odd function as well. So this is neither even nor odd. So this is the example for neither even nor odd function. Neither even nor odd. Once again I repeat this. Replace x by minus x. I am getting that minus x plus x square. But this is not equal to the given f of x. So this is not an even function. Can we take the minus sign behind the terms? I am putting x minus x square, but here it is x plus x square. So this is not equal to minus of f of x. So this is not even function. This is not odd function as well. So this is the example for neither even nor odd. Clear? Please don't skip the videos. If you skip a fraction of a second, you lose the concept. Yeah. Fifth one. E to the power x sin hax cos hax is a hyperbolic function, it's an exponential function. So fifth one, my f of x is e to the power ax or x. A is any constant, right? If I replace x by minus x, e to the power a into minus x, it will be minus ax. This is not equal to the power plus ax, so this is not equal to even function. So this is not an even function, right? When we say that the function is odd, minus of f of x, so it is equal to minus of f of x? No, because there is no minus sign behind the exponential term. It is only the power only, not in the base. So this is not equal to minus f of x. So this is not odd function. So this is the another example for neither even nor odd function, NENO function. Exponential functions are always neither even nor odd. Neither even nor odd. Clear? Now what about sin hax? Sin hax, cos hax. So sine functions, cos functions. What is sine of minus theta? Sine of minus theta, sin theta. Cos of minus theta is cos theta. Example for odd function is sine. Example for even function is cos. So what about f of x is equal to sin hax? If you remember, this result is very good. Sine of minus theta is minus sin theta. Even this is true for the hyperbolic function, right? It is even true for the hyperbolic function. So it is an odd function. Okay. So if I replace x by minus x, sin h of minus ax is equal to minus sin h ax. So is equal to minus f of x. So this is an odd function. What about cos hax? So f of x equal to cos hax. Replace x by minus x. So cos h of minus ax. Cos h of minus theta is cos theta. So is equal to cos hax is equal to given f of x. So this is an even function. Got it? So this is the fifth question. This is the fifth question. Clear? Now see the sixth one. It's a product of two functions, x into sin x, x into cos x, x square into sin x, x square into cos x, continue like that. Here I am going to use this concept, product of two functions. It's a very simple concept. Before going to that, I just try in the conventional method. Sixth one, I am considering f of x is equal to x into sin x, is right? If I replace x by minus x, I am getting minus x into sin of minus x. What is sin of minus theta? Minus sin theta. So this is equal to minus x into minus sin x. So minus to minus plus. x sin x. This is equal to the given function f of x. So f of minus x is equal to f of x. So that's why this is an even function. But as you know, the polynomial power with the odd degree is odd function. Sine function is always odd function. But under the product, what is odd into odd becomes even. Right, sir? So once I repeat that, this is x is the odd function, sine x is the odd function. What is odd into odd? This is even. So that's idea. That is idea. Clear? The same way, what about x squared into sine x? What about x squared is an even function. What about sine x is any of the odd function. So even into odd, the output is odd. Let us check it out. What about minus x to the whole square? It is plus x squared only. So this is plus x squared sine x. So but here sine of minus theta minus sin theta. So we have the minus sign. So let us see that minus x whole square is plus x squared. But sine of minus theta is minus sine theta. So minus sine x. So minus x squared into sine x. So this is equal to minus of, what about this one? This is about the given f of x minus f of x. So f of minus x is equal to minus f of x. So by the definition, it is an odd function. Right? Even though we can use this shortcut method, product of any two functions, one is even and the other one is odd. It's an even degree polynomial terms even. Sine function is always odd. Even and odd is odd. So the output is odd only. Even though by the conventional method, we can replace x by minus x by using the trigonometric identities. Sine of minus theta is minus sine theta. We get once again the same answer. What about this x cos x, x squared cos x? Let us see that. X cos x, x squared cos x. Yeah. F of x is equal to x cos x. So I am not talking about the intervals because intervals everything comes under minus pi comma pi 1. Right? X is an odd function. Clear? Cos x is an even function. So what about the output? The output is probably odd function only. This is the answer. Even though let us replace x by minus x by minus x, cos of minus x. What's the cos of minus theta? Cos theta only is equal to minus of x into cos x. Otherwise, is equal to minus of f of x. So that's why this is an odd function. So the same answer. So this is another way to get the even or odd. And what about x squared? So f of x is equal to x squared into cos x. So x squared is even function. Cos x is also even. So the output is even function. Clear? Right, sir? Now what about the modulus function? Modulus functions are always even. Right? So let us see the seventh one. Seventh one, modulus. What is f of x is equal to modulus of x. When I replace x by minus x, is modulus of minus x equal to plus modulus of x is equal to f of x. So this is an even function. Sir, modulus functions are always even functions. What about the other one? F of x is equal to modulus of sin x. If we replace x by minus x, modulus of sin of minus x. What is sin of minus theta? Minus sin theta. So modulus of minus sin x. Under the modulus sign, this becomes plus sin x. So this is equal to f of x. So this is also an even function. Got it? What about mod cos x? The same idea. What's the mod of cos x? So mod of cos x is nothing but minus of, yes, cos of minus theta is cos theta. So this is equal to f of x. So modulus functions are always even function in the case of single interval. Constant functions are also even function in the case of single interval. It can be defined in the single interval. Suppose it can be defined into more than one interval, then the answer may not be true. Let us verify that whether it is even or odd, or sometimes neither even nor odd, by using this way. Thank you for watching our YouTube channel ADC Max. Thank you so much.